Alright, let's go. Hook them out and see. Alright, so the diagram below shows 3 items stored in a stack with sequence of operations. We'll try to form the stack from the initial state to its final state. Alright, so the stack has CAB, and we want to get ACB. Okay, so we should. B stays at the bottom, so that doesn't move. So C has to come out. A has to come out. So you pop the C and pop the A, and then you push C and then push A. So your A should be the answer here. Alright, next question is, which of the following abstract structures would be implemented by an application like Microsoft Word when it utilizes the undo button? Should be a stack for sure. Yeah, that one should be correct. D. Because, yeah. 3, one major difference between a stack and a queue is that stack use 2 ends of the structure while queues no, this is wrong. Stacks only use 1 end of the structure while queues use 2 ends of the structure. This is correct. Queues require dynamic memory and stacks do not. That's wrong. Also, that's a linked list. Stacks require dynamic memory while queues do not. No, that's wrong. Okay, so B is the answer here. So 3 is B. 4, item 4 refers to the. We've seen this one before. Which order would be a pop? Well, the first thing I do with the pop is check to see if the if you have anything to pop. So the only thing that has a if here is the 2 and the 9. But as if pointer is a resize, that definitely is not it. So if pointer is not equal to 0, that means if the stack is not empty. Yeah. Actually, it should be if pointer is not equal to -1. But they have not equal to 0, so I'm not too sure why. Because if the pointer is at 0, that means there is a value. Because 0 is a value in the stack. But if they say so, yeah, so we definitely had to start at 9. So our options are either A or D. But the next thing that we have to do is take the value from the array and put it inside a variable called elements. So we put it inside elements. So we still fighting between A or D. And then the next thing now is to, after you put the value inside the element, what do? You have to carry down the pointer. So carry down the top by 1. So carry down the top by 1, it should be that. That'll be V. So the answer is D here. Kind of blurry here. Which of the following is true for both linear search and binary search? On average, you search half the list. That's wrong. That's only binary search. In the worst case scenario, they search the entire list. That's wrong. A binary search doesn't search the entire list. It could be used for searching an ordered list. Both of them, yeah, that is true. They require that the list be ordered. No, that's only for a binary search. So the answer here is C. 6. This is the ant, frog, grasshopper, bee, fish, snake question. I'm going to have to look this over. I'm sure I did this already, but let's just do it again for old time's sake. It's how much? 1, 2, 3, 4, 5, 6, 7 items. So let's create an array with 7. Let's start with, alright, so it's frog, ant, an, operating block letters to make it easier. F R A N D O G R B E F I and S. Okay, so for the selection sorts, the next thing that's going to happen is we're going to compare FR with anything that comes before it, and that's AN. So AN and FR will switch because that's the smallest value. So DOGRSN stay the same. Alright, so now that AN is locked in place, our next job is to break down the others. So we have FR and DO. Anything comes before F, A, B, C, D, D, O. D will come before F. There's BE also. So we have the BE and FR will swap. Everything else is the same, so DO, GR. Alright, so now the BE is locked in place. go again. Oh, AN was still here, yeah. So AN and BE have been sorted. And we continue. All right, now we're checking to see if DO is going to swap with anybody else. Nothing comes before D alphabetically. So DO will stay there and DO gets locked in place. There was no swap there. So we left with GR, FR, FI, and SN. And then we go again, which is now AN stays there, BE stays there, DO stays there. All right, so now we're checking to see if GR, A, B, C, D, E, F, G, F comes before G, so GR and F. I will change, it'll swap, so FI will end up going there, and then GR will end up going here because that's how the swap will take place. FR stays there and SN stays there. So we lock up to FI now. And then after that, well, there's really no more swapping to take place after that because everybody in the same spot. But we will check the FR. FR still coming before GR, so FR stays here. No change, locks in place. The AN will stay there. BE, DO, FI. This is a really long multiple choice question. We'll go there now. And then we continue. The GR and the SN won't swap, so that'll be locked in place, and then well, that'll be rest, right? So AN, BE, DO, FI, FR, GR, and SN. Okay, that is all we have there. All right, so now we can just look at the things and see if any of them do exist. All right, which of the following will not be obtained at any point? Do we have an ant, a frog, a dog, a grasshopper, bee, fish, and snake? Ant, a frog, ant, frog, dog, grasshopper, bee, fish, snake. All right, so this one does exist. So we have that one there. Do we have an ant, bee, frog, ant, bee, frog? There is no ant, bee, frog for sure. So this one does not exist. So far the answer is B, but let's just double check the others. Ant, bee, dog, fish. Ant, bee, dog, fish. Ant, bee, dog, fish. That ant, bee, dog, fish. Frog, grasshopper, snake. That is this one right here. So that exists. And then ant, bee, dog, grasshopper, frog, fish, snake. That is there also. So this one does exist also. So these exist. So therefore answer is B. All right, next, number 7. Woo, blurry. Using the selection sort algorithm, what would the array above look like after 3? I'm guessing it will be 3 passes. Yeah, let's say 3 passes. All right, so the selection sort algorithm is going to take, that's a 30, I think that's a 30. That is a 32. That's a 24. That's a 18. That's a 7. And that's a 3. I would hope so. All right, selection sort would be, first pass would be 3 and 30 would change. Next pass would be 7 and 32 would change. Next pass would be 18 and 24 would change. It's kind of what it would look like. All the other numbers should stay the same, if I am not mistaken. Ooh. My eyes hurting here, but yeah, so the 32 would stay there, 24 would stay there, the 18, the 7, and the 3. Then this would be 3, 7, 24 would still stay here, 18, 32, and 30. Then 3, 7, 18, 24. The 32 and the 30 would be the last thing I'd have to swap, but they only asked for the first 3 passes, so let's just go with that. Yeah, so A is the correct answer here. So number 7 is A. Yay. All right, number 8, which is true. Which of the following statements is true? We remember this guy here. The bubble sort is very simple and therefore efficient. No, it's not. selection sort performs the same regardless on the size of the list? No, it doesn't. The bubble sort performs less efficiently than a selection sort on longer files. That is true, correct here. The selection sort starts by finding the maximum element in the list and swapping it with the middle element. That's wrong. So C is the answer here for sure. So number 8 is C. What number this is? 9. Consider a circular queue with a pointer near a pointer array that references the location of the array of the queue. Okay, cool. It ranges from 0 to 4. So you have 0, 1, 2, 3, 4. Alright, good. And the front pointer is set to 0. We don't know what array is, but we went through this already, so let's do it one more time just to make sure. NQ is going to put a value inside here, so that means the array is going to be here. Then another NQ is going to put a value inside here, so that means the array is going to move up to that. Then another NQ is going to put a value inside there, so that means the array is going to move up to this spot here. Then DQ is going to take this value out, so that means it's going to take it out, and then the front will have to move up. So we just did NQ, 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 DQ, right? Now we have to do our next DQ. DQ will take this value out from location 1, and the front will move up. Now we have to do another NQ. So NQ will put a value inside here, and then the array will move up 1. Then we have another NQ, which will put a value inside here, and then the array will move up 1. And we have another NQ, but because it's a circular queue, it's going to circle back here, and the array is going to end up here. And then we have a DQ, which will take out a value from here, and then the front is going to move up to this spot here. So that means front is going to be at location 3. Number 9 is D. We have proven it. All right. Number 10. All right, so this is an incomplete algorithm, blah, blah, blah. One of the hardest parts is I've worked this question out already, but we have to power through and work it out again to make sure that there is 0 doubt in our answer. Okay, this is a linear search. Okay, so that means it's supposed to just search through an array and see if it found it or not. So we have this thing called flag. I hate these flags, but okay. Repeat, if list count is equal to target, then flag should say true. So we definitely, all of them saying flag true, so good. Flag equal true. Then end if. After you end if, you'll have to go up by 1 because you're looping through. So all of them say add 1 to count. Okay, cool. Add 1 to count. After that, you keep going inside this loop over and over and over and over and over until you finish running through the count. So the count will go up by 1 each time. And then if flag is equal to false, no, sorry, until flag is true or count is equal to n minus 1. That means you reach to the end of the array. I would think it's n minus 1 because array start at 0. Yeah. So it should be count is equal to n minus 1. And then if flag is false, then you would print target not found. So that leaves us with A. So 10 is A. Okay. Next is 11. The target is something binary search. Oh, the target value is something binary. What is that? How many comparisons are made before it can be concluded that the letter I doesn't exist? Yeah, okay. All right, so first comparison in our binary search will be to split this thing in half and compare the middle. So it will compare the F. It will be like, are you an I? No, you're not. What comes after F? So that means we have to move the mid up to here, and then the mid, and then so low is here, and high will become here now. Then we compare the middle there. That's a second comparison. This is comparison 1, this is comparison 2. And then when we realize, okay, there is no K there, where does I fall in terms of K? I comes before K. So therefore, we will have low and high will be here, and we'll compare to G. So that'll be 3 comparisons. 3 comparisons, because that's the answer. 12. Okay. This is a queue. It refers to one information with a queue, and the set of instructions will not be performed on the queue. What is top front? Why did they call it top front? It's supposed to just be front. So I guess in all the values supposed to just overwrite each other. Okay. So we will get 71, then 81, then remove 71 will go, then add 91, then add 101, then remove 81 will go, then remove 91 will go, then remove 101 will go, and then add 121, which will go here. Something is definitely wrong with this. I mean, technically speaking, when you remove a value from a queue, it doesn't actually remove it. It just acts like it's not there. So let's do this again. We'll just cross it out. So the top and the front, well, the front is here. All right, so front, 21. Add 71. 71 goes there. Add 81. 81 goes there. Remove means act like 71 is not there, but it's really still there. And then add 91, and then add 101, and then remove 81 and act like it's not there, remove 91, act like it's not there, remove 101, act like it's not there, and then add 121. Something's wrong here. This queue has 5 elements, but the answers have 6. What? Do you see that? Why is there 6 elements in the queue and there are 5 elements in the question? These are the things you have to, stop and ask yourself.
How is the Ministry of Education in Trinidad, in Guyana, in Jamaica, in Barbados allowing CX to do this to us still?
So I guess that the closest answer to 71, 81, 91, 101, and 121 is C. But where did 61 come from? Where did this block come from? The mystery will never be able to be answered. No one will ever know. Okay. Item 13 refers to the following segment of an incomplete algorithm for sorting an array. Okay, this one is the bubble sort. Yeah. Alright, so for position 1 to n minus 1 do if plus position equals plus position. Okay. Alright, this is the flag drama again. So we'll just set the flag to true. Because if whatever is in position, previous position is greater than what is in next position, then flag equal true. Alright, we'll live with that. The next thing you have to do is just do a swap. And to do a normal swap, your swap is kind of straightforward. You have to drop the value inside temp. Which one does the swap properly? Oh, I remember this question. Okay, we can't just put flag is equal to true yet. We have to figure out which one of these does a proper swap. The only one that does a proper swap is this one, where you take the temp and put it, then you take the second value and put it inside the first value, and then you update the second value with the temp. Anybody else does the swap properly? No, this is not a proper swap. This is not a proper swap either. This is not a proper swap either. Alright, so the answer is B by default, just because that's the only one that does the swap properly. So we'll go with B. The whole temp thing there was just to throw you off, I guess. Yeah. Alright, next, number 14. A circular queue is implemented. We assume that the locations range from 1 to 4. Okay. Alright, so insert job 1. 1, 2, 3, 4. Insert job 1. We'll go inside there. Insert job 2. We'll go inside there. Insert job 3. We'll go inside there. Print job 1, which will take out 1 because it'll be out of there. Print insert job 4 will go inside there. print job 2 will come out like that, and then insert job 5. So it should have 5 space, then 3 and 4. 5 space, then 3 and 4. All right, D is the answer. And then number 15, in which of the following situations would the implementation of a queue be most appropriate? It will be most appropriate. Q would be for rescheduling CPU time. Yeah. My eyes are bad. Okay. Or the paper is blurry. Alright, number 16. The chart best illustrates a top-down model because it goes on the top. Down. Top down. Which of the following are examples of functional requirements? Tricky. However, functional requirements are things that the user has to be able to do. So, like input a value, print a record, something like that. So, D. None of these. All of these are non-functional. They all work in the background. Alright, next one. 18. The main goal of a component testing is to, well, if you're testing a component individually, it would definitely look for faults in the components. But let's check through the other answers to make sure. Demonstrate our system meets requirements. No. Increases supplier's confidence. No. Test how one component interacts on our system. No. Yeah, so that should be A. I think. Yeah. Logically speaking. That one kind of like a little bit of common sense. Yeah, the evolutionary approach is being used to develop a software application. Which of the following are types of evolutionary development? Evolutionary. Okay, the thing about it for this question is I don't know if rewind approach is a thing. I think rewind approach is a thing, but evolutionary definitely has a bit of exploratory stuff in it, and there's throwaway prototyping for sure. So I can't say that rewind approach is evolutionary. If rewind approach is a thing. I think it's a thing, but I'd be lying if I tell you I was sure. Alright, the process of risk management is best illustrated as you should identify for sure. Okay, cool. All of them identify. Well, you can't plan before you identify. So these two out of the run-ins one time. Identify. And then you should analyze before you plan. You can't plan then analyze. That's kind of weird. All right, so B is the answer. All right, how many entities can be identified? Well, here is where we have gone to die, and I'm going to have to die on this hill and say the answer is 4. Because, yeah, orders could have an ID, customer could have an ID, car could have an ID, and payment could have an ID. Basically, each one of them can have their own table. So we'll go with 4. We'll go with 4. And we'll die on that hill. If you see that, choose 4 boldly, bravely, even though this question is still up for grabs. Alright, the company is interested in replacing its current software system with a new system. The company is located in various Caribbean territories and has many employees. Well, this one is a giveaway. Like, the previous iterations of this question had lots of intricacies, but this one is clear. It has many employees. Boom. Questionnaires, for sure. Easily. Because there are a lot of people. Questionnaires are your best bet to get a large amount of information from all of them. A large amount of data. I told you which of the following software shares a limited feature of the software with other users at no charge for a limited period of time. Should be a trialware. Yeah, trial software. Freeware is free, shareware is I can't remember what shareware is. Open source is totally free. Yeah. 24. A consultant was hired to implement a business logic application for a particular company using the following implementation steps. Which of the following is the best way in order to steps for implementing the application? Alright. So usually you should design first. So this will definitely be one that is correct there. After you design, you can't train, you can't install, you can't test, you should code it. So yeah. Then after you code it, then you should test it. After you test it, then you should install it. And then you should train the people. Yep. So that means 4 should be first, which will be these two here. After 4 is, yeah, after that, yeah, you're good there. B is the answer. Ooh. Alright, so for a process model defined by its approach, which involves refining an initial system based on user input. Once you say user input, that means evolutionary. Formal transformation, not even on the syllabus anymore. Reuse-oriented, no. Waterfall approach, and that's rigid. Evolutionary, for sure. And we're going. Which of the following threats is a destructive A destructive program which an internal computer replicates itself without any human intervention? You have virus? Yeah, virus for sure. Worms replicate themselves too, but a virus. Which of the following terms represent types of software maintenance? There are, I don't know what's defective maintenance. Defective is crazy. Very good. Adaptive and corrective. Defective software maintenance, I was like, you purposefully try to put a defect in it or something? Don't know. Alright, which of the following statements is true of data flow diagrams? Data cannot be moved directly from one store to another. That is correct. Data may flow in both directions between symbols. No, that means you have like a double arrow. You can have a double arrow like that. A process can only have one output. No, that's wrong. You can have multiple outputs. Data flow to a store means retrieve or use. No, that means store. Yeah, so A. Which of the following design processes refers to identification of subsystems and their relationships? Yeah, this is kind of like just straight notes. Just need to know. Architectural. A data structure is definitely that component interface. I don't know even what interface is. Design processes. Yeah. Probably is a thing, but architectural just kind of just screams subsystems. Break it down piece by piece, sort of, kind of. And they tell you which of the following types of testing is done to confirm that changes in code of software do not affect the existing functionality. System testing, no software testing, white box testing. All of these are tests, but they don't check to see if it's testing the functionality. Regression means if you add something, did you make it worse? So regression testing is like, did you break it while you tried to add something? It's almost like food. If you add something to the food to make it taste better, did it actually taste better or does it taste worse? You like pour more salt and then never taste it after, and then the food ends up too salty. Which of the following pieces of information is not contained in a process control block? Which of the following pieces of information is not contained in a process control block? No, okay. Now the process control block, it could tell you the amount of, it can't tell you how long it will take to completion though. It could tell you how much CPU time used, because every time it uses the CPU, it'll keep track of it. So it definitely has that, has the priority, has the process ID, but it doesn't know the estimated time to completion because you don't know how long you're going to take again. Because you don't know how much time you're going to have. So I was 31, I would say A. Yeah, I would say A. A system in which the processing of data is done in large groups simultaneously, non-stop, and in sequential order. Well, that's batch for sure. Once you say sequential, batch. Robert developed an interface for users in his company who are not so technologically savvy. The software for which the interface was built contains more than 200 features. Try to follow user interfaces to the most used. If you're not too technologically savvy, that means graphical user interface is your friend. Because it has color. People love colors. I think. Yeah, people love colors. Alright, our webmaster decided to design his website offline and upload it. Alright, once you're uploading to a web server, that means you're using FTP, file transfer protocol. Because GSM, that's for phones, UML, you don't want to know what that is, HTML, that's for websites. So, FTP, file transfer protocol. And then 35, within Firewire refers to, why is this still on the syllabus? This is not supposed to be on the syllabus still. How is this even there? They took this off the syllabus in 2022. Okay, FireWire is a high-speed serial bus system for your general information, but nobody uses FireWire anymore. Everybody uses USB-C. Yeah, everybody uses USB-C. Okay. Which layer of the OSI model acts as a translator between the application and the network? What? Okay. Translator between the application and network. Okay, so we have please do not touch Steve's pet alligator. A translator between application and network. So the network people are like up to here, transport and network and thing. And then the application layer is like on top here. So who's between those two? Presentation and session. Presentation and session is like there. Well, the only answer will be presentation because application layer is but transport is between application. Anyhow, transport is basically transport and networking. Network layer at the same time. This one kind of weird. I'm not grasping what they mean by translator between the application and the network. Which application? Like the application that opens the file? Like Microsoft Word or Excel or whatever application is supposed to take the bits of data and present it to you. The only one in between there is presentation. But this one is a weird one. I can't land on a perfect answer there because that question is quite ambiguous to me. Nope. Don't know. Presentation is the only thing that makes sense because that's between application and network. Although transport is between also, but transport is part of networking. Let's move on. That's the only one that's iffy for me so far. Alright, running process initiates an input request to get data from the keyboard. Which of the following state transitions will take place when the data is made available? Alright, so you have to get data from the keyboard. That means you are currently running. When the date, so you could either be ready, running, or blocked. If you're running, that means you're inside the running state. And you wait to get something from the keyboard, so you'll head down to blocked. And then when you get information, you go back up to ready. So what happens when the data is made available, you will go from blocked to ready. So that'll be B. What does the diagram above represent? That's a deadlock for sure. Deadlock. Which of the following determines the amount of time a running process gets to use the CPU when a run is a fixed time? Yeah. The order of arrival, no. Priority of the process, no. Estimated running time, nope. Now this question has me rethinking the previous one, which is, do you know the estimated time of right, cool. Number 40, a foreign key is an attribute in a table. Thank you very much. Whose values match the primary key? That seems correct. Is strictly used for data retrieval purposes. No. Is uniquely identifies each running table. No. Is a storage key in another table. No. Yeah, it should match the attributes in another table. Match the values. Values match. Yeah, 40 should be A. Alright, which layer of the OSI model handles data transmission between host computers? That should be the... See, the thing is, the network layer is responsible for determining the best path for you to travel, because it does have the routing. It does have the job of doing the routing based on the IP address. So it'll be like, okay, I have an IP address and I know what the destination is, and I'm going to choose the best route. And after it selects the most efficient route, the transport layer will now alright, we'll go with transport. Because the word transmission means the movement of the packets from one place to the other. So the actual movement of the packets is done by the transport layer. The network layer picks out the route that it should go, but the transport layer actually sends them from one place to the other and ensures that they get to the correct place. So yeah, we'll go transport. We land on that from now on forevermore. Alright, which of the following outcomes relates to the use of a virtual memory? Results in fast execution speeds. Okay, cool. No. Yeah. I mean, ensures that memory works faster. No. Creates an illusion that the computer has more memory. Yeah. Virtual memory. It's literally says virtual memory. So let's go with that. Alright, 43. Which IEEE standards are being employed to set up our wireless LAN for greater than 20. So yeah, look for the 5 gigahertz ones. 5 gigahertz would be A and 5 gigahertz would be G. Even though the syllabus does not explicitly say you need to know G, this is just beat me every single time I see this question. Because alright, then 44. A user wants to send a large file over a LAN. What measure can the user employ to transmit the file efficiently over the network? Well, efficiently. Large file. Once you see large file, compression is really what to do. Encryption, password fragmentation, all that is encryption is security, password is security. But efficiently, compression. For sure. And then 45. Which of the following phrases best describes paging? Once you hear paging, you're trying to link memory to frames and pages to chunks. Think of memory as the more technical term. Frames will be the more like raw stuff. Pages and chunks sound cooler. Which one says division of documents to smaller chunks? No. Assignment of chunks are programmed to frames of main memory called pages. No. That's because that's mixing up frames and pages. Chunks of a program called frames to different secondary storage media. No. Chunks of a program called pages, right, to chunks of memory called frames. Memory and frames and pages and program. What? Pages to chunk. No, pages to program. Sorry. Pages to program. Sorry, program to pages. Program to pages. And memory to frames, yeah. So it could be program or processes would be assigned to pages and then memory to frames. Yeah, so D. Okay, cool. That is all the newer questions. If there are any newer questions, I can't remember how much questions are new, but